Welcome to Magnalytix here at SMTA International. Delighted to be joined by Mike Bixenman. Great to see you again, Mike.
Good to see you, Trevor.
Yeah, okay. So last time we spoke about Magnalytix and your test coupons that you use. You had about half a dozen. And I'm looking here today, and it seems to have multiplied quite a bit. Tell me what's going on.
Well, a lot of that's driven by the client or the customer.
Mm-hmm.
For example, we had a contract manufacturer that came to us and said, hey, we build for multiple clients. And in some cases, we build for the high-end defense contractors. They want an objective evidence plan. They want to know that the process that we build is reliable.
Right.
And so they requested a set of test boards that could build both top side, bottom side, through hole, surface mount, and they wanted a low complexity, medium complexity, high complexity.
Mm-hmm.
We think about high complexity, we're thinking about very low profile parts like QFNs, dual row QFNs, micro BGAs.
Right.
So essentially what we do is we try to listen to the customer and we engineer test boards that can help, that we think are representative of the hardware that they're building.
Okay.
And so what they do is we build up the test boards, we build the dummy components, we sell them as a kit, and they'll buy the test boards, they'll build them in their factory, they send them back to us, we'll test them with SIR, and we can also test with IC, we can do a myriad of different tests for them.
Yeah.
And then afterwards, we do a full kind of failure analysis on the component or the assembly itself. We'll remove the components, we'll look at the residue patterns, we'll compare them to the SIR test values, and then we write the objective evidence report.
Right.
We give back to them the objective evidence that they can supply to their design authority, to their customer, to show that they are building to their specification.
Their specification, right. And you've taken different approaches to this. I mean, you've got, for example, one test board here which you've done in a fairly simple construction, medium construction, and complex construction. Why did you do that?
Well, in some cases, failure is really component specific, and it's also process specific. But when you look at these really low profile components, like on this is a glass test board, which is really cool.
Yeah, I know. I was going to come on to that in a minute, but never mind.
But like on these components, they're bottom terminated. And with a bottom terminated component, you have a very small gap. And whenever you have a small gap, you got a lot of solder feature under there. So there are several things that can go wrong, and the lower the gap, the more residue that you collect underneath the component.
Yeah.
And if not fully outgassed, it can be soft or pliable.
Yeah. So one of the things I noticed about this glass substrate is, you know, as you said, the beauty of it is you can see what's going on beneath after you've processed the device. But I mean, my question is, does glass behave differently to FR4 substrate?
It is true that there are some differences, and one of the things that we try to do is we try to build components that have a similar CTE
profile. Yeah.
Profile, but it is true that, like, if we take the same substrate on an FR4 and we built them up, we see similar patterns. But the beauty of a glass substrate is that it's very good for characterizing your process. Let's just take, for example, that you're going to clean your test cards, and you want to set up your process parameters. You want to understand how long do I need to be in the wash, the rinse, what's the concentration, which is the best chemistry. Let's say you got different solder paste, which one removes easier or which one's more difficult to clean. A board like this allows you to see the effects immediately without doing destructive removal of the component.
Right.
So it gives you a lot of information. The other thing it does is that because we can electrically test it in temperature and humidity. If we see leakage currents, which leakage currents are small metal fragments, dendrites that start to grow away from the conductors of opposite polarity, we can see them clearly and we can image them. So we can understand a lot about the process. So let's just take, for example, you use something like this. You characterize and build up your process, your parameters. Then you go back to a standard test board. You use that to qualify your process. You know that it's going to be good because that's pretty rigid test in its own right. So it's a tool.
Right.
It's a tool to help you understand what you're dealing with, and it helps you understand the problems up front so that when you do the testing, you have a high chance of being successful.
Right. So I mean, as you said, you can see the leakage currents and some of the dendritic growth on the glass substrate. But if once you see that, you can also run the same test on the FR4 version that does the same one. And then remove the components, and you'll actually see the difference in the spread. But
so when we're doing a paper here at the show on this glass substrate. It'll be presented tomorrow by Vladimir Stick called PBT Works. But one of the things we did is that we built this up with 3 different solder pastes. One of the solder pastes used adipic and succinic as the activator. One used succinic and one used maleic and adipic. So we had different levels of activation. And when we did our DOE, we built up so many of these boards, and we built these at the same time. We put them under the same processing conditions, and we tested them.
Right.
So we tested the glass and the FR4 versions, and what we see is similar results.
Okay, excellent. Yeah, well, it certainly looks like you've taken this to another level, Mike, the level of testing. But as you say, the demands for objective evidence nowadays are so strong that it's necessary.
Especially your contract manufacturer, people who build these assemblies, they need third-party validation. And what Magnalytix can do for them is provide them with that third-party validation, which helps them go back to their customer and demonstrate that they can build to their design specification.
Right. And the important thing is of course, is that Magnalytix does this as a service or as a supplier of the equipment and coupons.
That is correct. We also build the SIR instruments. And we continue to evolve. What's interesting about our tools is that all the analytics, they're smart tools, are written through the code. So we do all the test analytics in the instruments. It's real time. You can see it, see what's going on as the test runs. So like, for example, we have clients that we do testing services for, and after a day they can call us and say, hey, how's my test running? We can just instantly download a test report and email it to them, and they can see real time what's going on.
Wow. Yeah, that's powerful. That is powerful. Well, it's a great tool, Mike, and it keeps evolving, and I can only say congratulations on some great work, and thank you for sharing it with us.
Well, any company, any business is driven by our customers, and our customers have needs. And if we listen to what they need and try to bring a product that helps them satisfy that need, your chances of success are a lot greater.
Absolutely. I couldn't agree more. Well, as I say, congratulations once again, and thank you for showing it to us today.
Okay, you're welcome, Trevor.
Thank you.
Thanks.